Hello everyone, welcome back to my series of videos on solving LeetCode problems. And now we're solving the 1 to 8 longest consecutive sequence. What's this about? Given an unsorted array of integers nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in O(n) time. So, what do we have to do? So we have this nums, which is 100, 4, 200, 1, 3, 2, and the output is 4 because the longest consecutive element sequence is 1, 2, 3, 4. Therefore, its length is 4. And we need to write something that's n log n that looks at this. So, what I'm thinking here is that I can do the following thing, which is, hey, let's iterate over the array and save the smallest element. And then, maybe not smallest element, but my idea is, let's see if 100, we found 100. So that means that for the longest consecutive element sequence to exist with the number 100, then the number 99 must exist. So we check if 99 exists, and if so, we do something with it. I just don't know what. So we just say, hey, 99, here I am, on the dictionary, or try to look for 99. And then if we found 4, it's the same thing. Let's try to find a 3. 200, we try to find a 199. Find a 1, we try to find a 0. Find a 3, we try to find a 2. But it's actually interesting because here at 3, the 4 already tried to find a 3. So at this moment we can say, hey, I know there's a 4 because I know a 3 was tried to be found, which is pretty cool. So then we move on to the next, and the 2 we try to find a 1, but also the 3 try to find a 2, and then we can link them. So I guess what we need to do is, let's say, make the directory 1 to 8 longest consecutive sequence. Just delete this or shut it down. Solution.py, and we come here and we pass solution of longest consecutive nums. Let's do this. Let's call them like alone numbers or something like alone numbers for the set. Why am I creating this? I think I will use it for numbers that are not linked to anything. But maybe, and I don't know, so for num in nums, I think that we need to say that 100 I don't know. Let's just do found numbers. But we don't even need to iterate. Let's just say found numbers for set and for num in nums found numbers dot add num, and we add the 100, and then I don't know, we add 100, and should we look for 99? Numbers needed. So if we find 100, I think we need to link it. So I'm going to change this to a dictionary of int to int. Numbers length. It starts like this. Let me comment this out. For num and numbers, I can say if num, in this case 100, is in numbers length dot keys, this means that, actually let me move this. Let me do 1, 2, 3, 4, 100, 200. So if num is in num's length, well, first of all, 2 will be in num's length if 1 says, hey, I need a 2. Or else, let me just go and say, if number's length, if 2 is in number's length, then 2 is connected to 1. Then I guess if a 3 shows up, it needs to know a 2 existed. And if numbers and length. Okay, let's do numbers and length. So if a 3 shows up, then we need to get the length of 2. Do we? I don't think we do, actually. I think we just need to save them on a set. Okay. Okay, I get it. Found numbers is a set of nums. So then we just go again for num and nums. If num minus 1 in found numbers, then we continue. It doesn't matter. Else, if it's not, let's check, and we want to return, okay, best length 0. Else, while true, if num plus 1 in found numbers, let's call it best length is 1. Num plus 1 in numbers, then I think we can say num equals num plus 1 new num plus equals 1, and best length, not best length but current length, plus 1 plus equals 1, and as break, and now best length equals the maximum of best length and current length. But I think that now if number minus 1 in found numbers continue, then if we get here, then we are at the lowest of everything. So I think we can go and say here that found numbers are remove num or new num. But we can put that here, the while true. And then at the end return best length. Run debug. Why? Best length, free. Oh, I think this is the edge case. If not nums, return 0. Submit. Okay, it worked. The results were green. So I'm very sleepy now, but I'll just recap what I did in case it was not clear. I pretty much did a counter on this, so I'm going to put it here. And then I create a counter, so 100 is 1. I don't even need a, oh no, not a counter. Did I use a counter? No, set, sorry, set. I create like a hash table of this. 1, 3, 2. And then I iterate over the array and I check 100. If 100 is part of something, then is a part of like the sequence, then 99 must also be, if it's the highest number. If 99 is not there, okay, never mind, let's continue. 4. Let's say 4 is the biggest number of a sequence, then 3 must be there. Oh, actually 3 is there. So at that moment, I do a while true, and I do like incrementation. So if 4 is there, actually let's remove 4, and when we remove, we say current length. Now it's 1 because we removed 1. Now let's look at 4 minus 1. Let's see if it's there. 3. Well, it's there. So length is 2. Same. 3 minus 1, 2. It is there. 3. And then 1. Go. Cool. Done. And now there's no 0, so it's good. So then we compare the current length to the best length. Is this 3? 1, 2, 3. Oh, yeah, of course it's 3 because I removed the comma that I shouldn't. Okay, then next we move to 200. Well, is there a 199 there? No, never mind. 1, is there a 0? No. 3. Actually, we already visited 3. That's why I'm saving. I'm removing them from the found numbers and I have this conditional here. So we already visited 3, doesn't matter. We already visited 2, doesn't matter. Empty array, game over. Well, I hope you guys enjoyed it. See you later.